All right, in this last example, I have y equals x cubed over x squared plus 1. Again, we're just going to check for symmetry, each of the three types of symmetry in this equation. So we'll start off with the y-axis. And with y-axis symmetry, remember we replace x with negative x and see if the equation changes. If it doesn't change after simplifying, then it has y-axis symmetry. And if it does change, then it does not. So we start out just making that change. So we have y equals now x. Both x's will become negative x. So this is negative x cubed over negative x squared plus 1. Now remember we said that negatives stay when there's a cube and they disappear when there's a square, right? You square a negative, you get the positive. You cube a negative, you still get a negative. And so we could say that this is equal to y equals negative x cubed over, now negative x squared is just x squared plus 1. And this factor of a negative on top could really just be moved out in front. It doesn't really matter where that's placed. I'll call it the negative of the fraction x cubed over x squared plus 1. What I want you to notice now is that the original equation contains x cubed over x squared plus 1. This one has negative x cubed over x squared plus 1, so it's the opposite of that. Well, that's not good. Okay, these are not the same. So this equation is not the same as this equation. They're opposites of each other. Okay, and so we'd say this is not equal to the original x cubed over x squared plus 1. And if they're not equal to each other, then we have no y-axis symmetry. No y-axis symmetry. All right, let's look at the x-axis for a moment. X-axis symmetry, we replace the y with the negative y. So it becomes negative y equals x cubed over x squared plus 1. Now, of course, we want to get y by itself to match up the equation. So maybe I multiply both sides by a negative 1. And I get y equals negative of x cubed over x squared plus 1. Well, again, I have the opposite of the original fraction there. And so this is not equal to the original x cubed over x squared plus 1. And so there is no x-axis symmetry here. Okay? So now let's see what happens when we do the origin symmetry. We're going to change both the x and the y into negative x and negative y. They're opposites. So let's try that out. So for origin symmetry, I want to replace both the y with negative y and the x's with the negative x. So this is negative y equals negative x cubed over negative x squared plus 1. And if I simplify, well, on the right side, I'll do the same thing. Negative x all cubed is really just the negative of x cubed. Negative x squared is just x squared plus 1. We'll add the 1 in there. And now this negative I could always pull out, so it's, I could write it, I'll bring it over here. It's negative y equals negative of the fraction x cubed over x squared plus 1. Now if you notice here, I still have a negative on this y, so I'd want to multiply both sides by a negative 1 to get the y by itself. Right? Or you could divide both sides by negative 1, however you want to do that. I'm going to multiply. So multiply by negative 1 there, multiply by negative 1 there. Here, negative 1 times negative y is positive y. And here, the negative 1 times this negative is positive, and so I just get the original x cubed over x squared plus 1. By multiplying both sides by that negative, the negatives cancel out on both sides, and we end up with the original equation. So when that occurs, these two things are equal, I would say that we have origin symmetry. Okay, so any point on the graph is going to reflect through the origin or across the origin.